Now we're going to verify an identity. And you can take a look at this one. It looks pretty scary. Remember, whenever you verify an identity, you start with one side, usually the more complicated side, which is going to be the right side, and you work your way over to the other side, make it look the same. So if I look at this, it looks like what I should probably try to do is factor. So the top, they just have a greatest common factor of secant squared. So I'm going to take that out. Secant squared x, open the parentheses, I'd have 1 plus secant squared x. And that's as far as I can take that. On the bottom, think of the bottom like this. This is 2 plus k squared minus k to the fourth. Your product here is a negative 2. Your sum is a positive 1. How that factors is 2 minus k squared times 1 plus k squared. So we're going to do that just with secants. So this should be 2 minus secant squared x and 1 plus secant squared x. And look how lucky we got. We get to cancel these two out. Common factor on the top and the bottom. Okay, so it looks like we got secant squared over 2 minus secant squared. So remember, another strategy is, well, just turn these things into sines and cosines. In this case, secant squared is the same thing as the reciprocal cosine squared. So on the top, I'm going to have 1 over cosine squared x, bottom, 2 minus 1 over cosine squared x. Complex fraction. To get rid of it, to simplify it, just multiply the top and the bottom by cosine x, cosine squared x. Okay, so on the top, I'm just going to have 1. On the bottom, I'm going to have 2 cosine squared x minus 1. Whenever I multiply this times this and distribute it to both parts, I know that 2 cosine squared x minus 1 is the same thing as cosine 2x. That's one of the double angle formulas, just kind of working backwards there. This is just the reciprocal now of secant of 2x. And I verified it.